Hi everyone, and welcome to our next example. In the last example, we looked at a parallel circuit, and we calculated the current in the circuit using a certain method. What we're going to do in this one is we're going to take a look at a different method. So we'll call this method 2. And to do it, we need to find the total resistance in this circuit. If I know that this DC source is 24 volts and R1 has a value of 2 ohms and this has a value of 8 ohms, I can determine the total resistance using a formula that looks like this, which is specifically for a parallel circuit. 1 over R total equals 1 over R1 plus 1 over R2. So 1 over R total, I'll just put T, equals 1 over, well, I know that R1 is 2 ohms, plus 1 over R1, that's 8 ohms. So 1 over R total is equal to, if I use a calculator and divide 1 divided by 2, that gives me 0.5. And 1 divided by 8 is 0.125. 1 over RT then equals, if I add these, it comes to 0.625. That's what 1 over RT is equal to. If I take my calculator and I go 1 over this here, that will actually give me the value of RT. And when you do that, it comes out to 1.6. So what does that mean? That means when the DC source looks out into this circuit, it sees two resistors in parallel. The total resistance it sees is equal to 1.6 ohms. So if I wanted to find the current that's traveling through A4, the way I'd find that is I total, which is really the current going through I4, equals the voltage divided by the total resistance. I know this voltage is 24 volts divided by the total resistance, 1.6 ohms. If you take out your calculator and you divide, I total comes out to 15 amps. That's exactly what we found in the last question, except we used a different method. We ended up with the same answer. Total current in this circuit traveling through A4, which is the same as A5, is 15 amps. That's it for this tutorial. Take care. We'll talk to you soon.